Today I'll be going over descriptive statistics. These help to describe data using measures such as central tendency, which include mean, median, and mode, as well as other measures such as range, variance, standard deviation, and the z-score. These measurements help to give an idea of what the data looks like and helps to present, organize, and summarize the data. Going over the central tendencies, you have mean, median, and mode. And if we're using a sample of 5 students, what they got on a test, and it is 77, 77, 81, 85, and 96. The mean is the average of the numbers. This can be found easily by adding up all the numbers in the data and then dividing by how many different numbers are within the data. The mean is a good indication of what the middle of the whole set looks like. So for this sample, we would take 77 plus 77 plus 81 plus 85 plus 96, which equals 416. Then we would take that and divide it by how many sample scores we have, which is 5. So we divide that by 5, and we get 83.2 as our mean. Next, we have the median. This is the middle number of all data points. If a data set has 2 middle numbers, you find the average of those 2 numbers to give you the median. The median is another way to see what the middle of the data set looks like, but it can help to eliminate outliers that may be skewing the data. In this case, we would take our set of numbers and we would take off 1 from the highest, 1 from the lowest, 1 from the highest, 1 from the lowest, and our middle number right here is 81. So that would be our median. But let's say that we had 2 numbers instead of just the single number that is left in the middle. Say that we had 81 left and 85 left. We would add these 2 numbers up together, which would be 166, and then we would divide it by 2 to find the average because there's 2 numbers, and that would equal 83. So if you have 2 numbers in the middle that are left over, you find the average of those 2 numbers. The next measure of central tendency is the mode. This is the data value that occurs most often. This helps to show a high group of a single data point. So we look for which data point occurs the most. So you have 77, 77, 81, 85, and 86. And we can see that there's 2 77s, and there's no 2 of any other number in our data sample. So we know that 77 is the mode because this occurs the most in our data set. First, we have the range. This is the difference between the maximum and the minimum, which helps to show how spread out the data is. So to find this, we take the highest number, which is 96, and subtract the lowest number, which is 77. So we have 96 minus 77, which equals 19, so that we know our data has a spread of 19. Next, we have the variance. The variance is the average number of the squared difference from the mean. To find this, you take each data point and subtract the mean from it first. So say we have 96 minus the mean, which is 83.2, and that gets us 12.8. And then next, to find the variance, you have to square this number of the difference of the mean. And so after we square that, we get 163.84 for our 96 values variance. You guys should pause and then find the variance for each of the rest of the 4 numbers right now. After doing this, you should have got 3.24 for 85, 4.84 for 81, 38.44 for both the 77s. Then after you have each of these numbers, you have to add them together. So we have 163.84 plus 3.24 plus 4.84 plus 38.44 plus 38.44. And this should give you 248.8. And then after you have this number, which is all of these numbers added up, then finally you just divide by the number of numbers you're using. So in this case, we had 5 numbers in our sample, so we divide this number by 5. And this gives us a variance of 49.76. After we have found the variance, we can then move on to finding the standard deviation. The standard deviation is a measure of the dispersion of the scores. This value helps to show how spread out the numbers are from the mean of the data set. In order to find the standard deviation, all you need to do is to take the square root of the variance. The standard deviation is very important for descriptive statistics. Since we have the variance that we got from the last part, all we need to do is take the square root of this number. So we have the square root of 49.76, and this gives us a standard deviation of 7.05. Using our standard deviation on a bell curve can help us to see and visualize what our data looks like. This is a normal bell curve that is symmetrical and not skewed to the left or to the right. In a normal bell curve, a large percent of the data within a given data set falls within the range of being one standard deviation to both sides of the mean. As you move away from the mean, you can see that it is decreasing as you move to one side of the data. From the mean, one standard deviation on both sides is about 80 or 68% of the total data. As you move 2 standard deviations away on either side, it increases to about 95% of the total data. And as you move 3 standard deviations away from both sides, it increases to about 99.7% of the total data in a normal bell curve. We can see that we have a mean of 83.2, so that is the very middle of the data. And then if we move 1 standard deviation to the right, we add 7.05, which is our standard deviation, to get 90.25 at this line of being 1 standard deviation. Then if we have -1 standard deviations, then we have the mean of 83.2 minus the standard deviation of 7.05 to get the standard deviation of -1. And you do that so on and so forth out to standard deviation 2 and standard deviation 3, where you just add the standard deviation twice or subtract it twice, or add it 3 times or subtract it 3 times to get these values right here. So you can see how the data is spread. If a sample set has a standard deviation that is a large number compared to the data set, then there is a large amount of dispersion. If the standard deviation is a small number compared to the data, there is not much dispersion. The standard deviation is important to find to know how the data is spread so that it can be easily described and visualized through a bell curve. When using a bell curve, it may be hard to determine where exactly a data value would occur on the graph, since you just have to estimate about where it would be. This is where standard scores come in. Standard scores can be used to show the location of a value within a data set. A common standard score used is the z-score. Z-score can be calculated by taking the number minus the mean divided by the standard deviation, and this equation can be found in your formula booklet. And this number shows precisely how many standard deviations from the mean this number is. A z-score of 0 is at the mean. A z-score of less than 0 is below the mean, and a z-score of more than 0 is above the mean. So if we were to find a z-score for a value, let's take 96 for example. This is the z-score equation, so you would put 96 as the x value minus the mean, which is 83.2, and then divide it by the standard deviation of 7.05. And then, after you do this, you get a z-score of 1.82. So you know that 96 is 1.82 standard deviations away from the mean of 83.2. Since we found the z-score for 96, we know exactly how far away from the mean the value is. Now I want you guys to find the z-scores for the remaining 4 numbers in the sample set using this equation, which can also be found in your formula booklet. Once you have finished these, you should have got a z-score for 85, which is 0.26, so you know that it is close to the mean because the z-score is low. Then you have for 81, your z-score is negative 0.31, which means that it's close to the mean, but it is below the mean because it has a negative. Then for 77, you have a z-score of negative 0.88. So you know that this is below the mean by 0.88 standard deviations. To review, we have the measures of central tendency, which you guys should be familiar with, which is the mean, which is the average, the median, the middle number, and the mode, the value that occurs the most. Then we have other measures such as the range, which is the maximum minus the minimum. We have the trickiest one, which is the variance, where you take a value and subtract the mean, then square that, and you do that for all the values in the data set. And then you take the average of each of those values to get your variance. Then, to find the standard deviation, you simply just take the square root of the variance. And then finally, to find the z-score, to find how far away from the mean value is, you have a value minus the mean divided by the standard deviation. Using descriptive statistics and the measurements that we found, you're able to get a picture of what the data looks like so that it can be easily summarized and described and giving you a more complex understanding of the data.